In example number 8, we take the limit as x goes to 0 from the positive side of x natural log of x. First of all, we're taking a limit from one direction because it's necessary relative to the function we're working with. The natural log function looks like this, and it wouldn't make sense to take a two-sided limit because this function doesn't have any values to the left of 0. So that's why we have to take a one-sided limit. All right, let's try plugging in 0 and see what we get. Plugging in 0 for the x, you get 0. Plugging in values of x close to 0 for your natural log, you're getting values that are gradually going down to negative infinity. So we have essentially a 0 times infinity or negative infinity in determinative form. So what we should do is either take that x and write it as 1 over x, or take that natural log of x and write it as 1 over natural log of x. Sometimes one is better than the other, sometimes both work. In this case, I'm going to go ahead and take that x and write it as 1 over x. So the limit as x goes to 0 from the positive side of 1 over x times the natural log of x. So I haven't applied L'Hopital's rule yet. I'm just doing a little bit of algebraic manipulation. From this step to that step, I simply wrote it as a fraction, just as a different fraction. So in this fraction, the numerator is natural log of x, and the denominator is 1 over x. Plugging in values of x close to 0 to the natural log, again, you'll get values that go to negative infinity. And for 1 over x, the graph of 1 over x looks like this. And you're plugging in values of x close to 0 from the right-hand side, so those guys blow up to positive infinity. So you have a negative infinity over infinity in determinative form, a candidate for L'Hopital's rule. So by applying L'Hopital's rule, we get the limit as x goes to 0 from the positive side. The derivative of natural log of x is 1 over x. The derivative of 1 over x is negative 1 over x squared. And here you want to be careful. Potentially we can apply another iteration of L'Hopital's rule because we get another infinity over negative infinity in determinative form. But with a little bit of algebra, can you see what 1 over x divided by negative 1 over x squared turns into? This is equal to the limit as x goes to 0 from the positive side. Again, you have a fraction of fractions, so you'll take the first fraction on the top and you'll multiply it by the reciprocal of the fraction on the bottom. So that's equal to the limit as x goes to 0 from the positive side of negative x. So this limit is a piece of cake. Where's negative x going as x goes to 0? The answer is simply 0.